Morning all. Today we're going to look at the probability of independent events. So as usual, I want you to write the headings down, keywords and the dates in Welsh underline. So click pause until you're ready to move on and then click play again. Good. So moving on to our starter. And we've got 5 questions in the starter. So I want you to click pause, attempt all 5. And when you're ready, click play and we will go through the answers. Question 1. Okay, good. Question 1. Round 6,754 to the nearest 10. So the nearest 10 means we're going to put our line between the 5 and the 4. The 4 doesn't affect the 5 because it's less than 5, so it leaves us with 6,750. To the nearest 100, the 5 does affect the 7 because it's 5 or more, so that gives us 6,800 to the nearest 100. We've got 5 cubed. 5 cubed means, or 5 to the power of 3, 5 times 5 times another 5. 5 5s are 25 times another 5 leaves us with 125. And how do we say this? Correct. Square root of 81. What number multiplies itself to give us 81? That would be 9. Question 3. 1,237 divided between 54 people. Keyword, estimate. Estimate the amount each person would get. So that means we're going to round 1,237. When I round that to one significant figure, that leaves me with 1,000. If you rounded it to 1,200, that's fine, we'll take that. But 1,000 is much easier to work with. I'm going to round 54 next, and I round 54 to 50. So I need to know how many times does 50 go into 1,000. If I cross off the 1 0 on the end, that allows me to do 5 into 100, which is 20. So each person will get £20. Question 4, it's division 1. When we have a fraction, 1032 over 24, it means divide. So we can put our bus shelter here, 1032, and divide by 24. Now, I don't know my 24 times table very well, so I'm going to write it here, 24. Add 24, 48. Add another 24, correct, 72. Add another 24, 96, and do one more just to make sure. Add 24 gives us 120. If we need more while we're in the calculation, we can add more to that. 24 can't go into 1, so we carry the 1 into 10, still can't go into 10, so we carry the 10 into 103. 24 goes, let's count it, 1, 2, 3, 4 times, so 4 times. 103 take away 96 leaves us with 7. Go 24 into 72, count that, 1, 2, 3. So our answer is 43. Describe the probability it will rain tomorrow. You could have said maybe it's 50-50, so we could describe that as evens. You could say it's likely to rain tomorrow. You could have said it was highly likely. You could also say it's unlikely or highly unlikely. So any of these we'll accept as a correct answer. What you can't say is that it will certainly rain tomorrow, so you can't say certain. And you can't say it's impossible that it will rain tomorrow. Those are our choices, so we can't have those today. And moving on. So, question. 3 red, 4 black and 5 blue cubes in the bag. 1 cube selected at random. What's the probability of selecting a red or a blue cube? So that's a nice diagram for us. Probability of selecting a red or a blue. And that word there is key, or. So we've got 3 red and 5 blue. Altogether gives us 8 out of a total of 12. So probability of selecting a red or a blue is going to be 8 out of a total of 12. So we write it like that. P red or blue is 8 out of 12. Now we can look at the individual probabilities of selecting red and blue and then add them together. So probability of red is 3 out of the 12. Probability of blue is 5 out of all 12. 3 add 5 would give us 8 out of 12. So probability of red, 3 out of 12. Probability of blue, 5 out of 12. So when you have OR, we add the probabilities. So we can write at the top here, OR means add. Good. Let's have that as a proper add. Good. Let's try another question. This time it says, find the probability of selecting an ace or a king from a pack of 52 cards. Here's our pack of 52 cards. How many aces have we got? So we got 1, 2, 3, 4 aces, and kings we got 1, 2, 3, and 4. So 8 in total. Probability of selecting an ace or a king. That or is key again. Means we add. 4 plus 4 gives us 8 out of 52. And remember, we've got to write it like that. P brackets ace or king equals 8 out of 52. Now we can do the individual probabilities again, like we said earlier. Probability of ace. Probability of ace is 4 out of 52. Probability of the king, also 4 out of 52. When we add these two together, we get our answer of 8 out of 52. So like we said earlier, OR means add. So I want you to pause, write number 1 as an example, and when you've done that, click play again. Don't forget to make sure you write OR means add. Good. Question. So this time I'm going to look at the chance of throwing a double 6 with 2 dice. So probability of throwing a 6 and a 6. If you notice now we're saying and. So it's a change this time. Probability of throwing a 6 and a 6. And what I like to do with these is to make a table. Now this table in probability is called a sample space diagram. And we can then put all the possible outcomes. 6 and a 6. 6 plus 6 will give us 12 on the dice. So if we said we had 1 blue dice and 1 red dice, all the outcomes on the blue dice are 1 to 6. All the outcomes on the red dice are 1 to 6 as well. If we roll the dice and then we add the outcomes, 1 add 1 would give us 2. If we were 1 on each one, a 1 and a 2 on the red dice will give us 3. A 1 and a 3 give us 4, and so on. And we can complete this sample space diagram. What I want you to do now is to click pause, copy the diagram, and finish filling in all the possible outcomes. When you're ready, then click play again. Good. Okay, so you should have completed that diagram, and you should have 2 and a 2 would give us a 4, 3 and a 2 would give us a 5, and so on. 5 and a 2 would give us a 7, 6 and a 2 gives us an 8. And those are all the outcomes remaining. So we're looking for the probability of a double 6. A 6 and a 6 would be 12. So a 6 on that dice and a 6 on that dice will give us 12. So probability of a 6 and a 6 is 1 out of all 36 possible outcomes. So you got 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So 6 times 6 is 36, so you get 1 out of all 36 possible outcomes you can get. So what's important then is to see when we've got AND here, it means we multiply the individual probabilities. So if I write probability of a 6 is equal to 1 out of 6 on the blue. On the red, probability of 6 is also equal to 1 out of 6. And if we multiply that, we get 1 out of 6 times 1 out of 6, which is equal to 1 out of 36. So we can, either way works. We can either draw the sample space diagram out, which is my preferred method, or we can identify each individual probability and then multiply. So when it's AND, we multiply. So if we put that on the bottom here, AND equals multiply. So what I want you to do now is to click pause, make some notes on this, and then when you're ready to move on, click play again. We'll look at another example. Okay, this time I've got two spinners and they spin independently of each other. So what I get on one spinner does not affect what I get on the other. On the blue spinner, I've got the possible outcomes 1, 2, 2, 3, and 4. And on the red spinner, I've got the outcomes 1, 2, 4, 4, 4, and 5. Okay. Oops. There we go. So probability of getting a 2 on the blue spinner is 2 out of all 5. Probability of getting a 4 is 3 out of 6. So 2 out of 5 times 3 out of 6 will give me 2 out of 5 times 3 out of 6 gives me 6 out of 30. So I've done the individual probabilities and multiplied them because it's AND. Right? I'm looking for the AND option here. So I can check if this is correct by using a sample space diagram, which I like. So there's my red spinner, 1, 2, 4, 4, 4, and 5. There's my blue spinner, 1, 2, 3, 3, and 4. Now I can add the outcomes. So if I go 1 and a 1, give me 2. Oops, didn't want you to see that quite yet. 1 and a 2 gives me 3. So what I want you to do is click pause, complete the diagram, and then when you're ready, click play again. And then we can check the answers. Good. Hopefully you got all those right. And if we check, probability of getting a 3 and a 4. 3 add 4 will give me 7. So a 3 here and a 4 there. So these are the outcomes I'm looking for. 7, 7, 7, 7, 7, 7. That one is a 2 and a 5, so I can't add that one. So those are my outcomes there. And 1, 2, 3, 4, 5, 6 outcomes out of a possible 30. So the answers match. So I can either use a sample space diagram or I can work it out by using the individual probabilities. Okay. And this is a general form of writing the AND law. If you have AND, you multiply. So probability of A and B is probability of A times the probability of B. So multiply. Make some notes. So click pause, make some notes, and then we'll look at a question then. So, if we roll a dice, probability of a 6 is 1 out of 6. 1 out of the 6 sides the dice has got. And to throw a double 6, as this statement tells us, it's much harder to get another 6. So to throw a double 6 is 1 out of 6 times another 1 out of 6, which gives us 1 out of 36, which we saw earlier. Okay, so it's a smaller chance of getting 2 6s than it is of getting 1 6. 1 6 is there, 2 6s is there, so it's a very small chance. What do you think is the probability of getting a triple 6 when you throw 3 dice then? So probability on one dice is 1 out of 6, on another dice 1 out of 6, and on the third dice is also 1 out of 6. So 1 out of 6 times 1 out of 6 times 1 out of 6 is going to be 1 out of 216. And as you see, that's even smaller on our, it's very close to 0, so it's a very small chance of getting 3 6s. Okay. So question for you. Rebecca has 9 colored beads in the bag, 4 are red, the rest are blue. She removes a bead at random from the bag, notes the color, replaces it. Then she chooses a second bead. Important that she replaces it because that keeps it independent. Then she chooses a second bead. So calculate the probability that Rebecca chooses 2 red beads and then a blue bead followed by a red bead. So what I want you to do is click pause, work it out, and then click play to check the answer. Probability of choosing 2 red beads. So a red bead first. So chance of choosing a red bead is going to be 1, 2, 3, 4 out of 9. So it's going to be 4 out of 9. A red and a red. 4 out of 9 on the first go, and then 4 out of 9 to choose it again because she's put it back in. When you multiply that, you get 16 out of 81. Second question, probability of a blue and then a red bead. So probability of a blue is 5 out of the 9 beads altogether. Probability of a red, which we got from earlier, is 4 out of 9. So it's going to be 5 out of 9 times 4 out of 9. That gives us 20 out of 81. Okay, so we'll stop there and then and carry on with this video for just a little bit longer. Okay, we're going to do one more topic quickly, and then you can, I know you're itching to get on with doing some calculations yourselves. Right, so as per usual, take the headings down and the dates, keywords, and underline. Click pause. When you're ready, click play again. Okay, so we're going to use tree diagrams to help us solve. We're going to look at independent events today. We're not going to look at dependent ones, so we're only going to look at independent events. Okay, so we can represent this following situation with a tree diagram. Peter has 10 colored cubes in the bag. 3 are red, 7 are blue. He's going to remove a cube at random from the bag, note the color, and then replaces it. So it's important we note that he's going to replace them. So he's going to put them back. And then he's going to choose a cube again and then record the information. So you can either go red or blue. So we can use a tree diagram. Looks like that. It's an odd kind of tree, but it's mathematical. So first choice, chance of choosing a red or a blue. Now they're 10, so the chance of choosing a red is going to be 3 out of 10. And then the chance of choosing a blue, so red, 3 out of 10. 7 are blue, so 7 out of 10. If you note, 3 out of 7 gives us 10 out of 10, which is 1, which is the whole probability. That's on the first choice. Then after he's got a red, say, he goes again, or after he's got a blue. So he got a red on the first go, and then he goes again. Now, because he's replaced them, the chance of choosing a red is the same again. So it's 3 out of 10 for a red. Oops. So those are our results. Chance of choosing a red is 3 out of 10. Chance of choosing a blue, 7 out of 10. And even though he chose the blue the first time, it's independent, so it doesn't matter. Chance of choosing a red this time is 3 out of 10. The chance of choosing a blue is 7 out of 10. Now we can work out the probability of choosing a red on the first go and then a red on the second go. So red and a red by multiplying. Because it's and, we multiply. So 3 out of 10 times 3 out of 10, 9 out of 100. Chance of choosing a red on the first go and then a blue will be 3 out of 10 times 7 out of 10, which is 21 out of 100. Then, if he got a blue on the first go with a chance of 7 out of 10, chance that he chooses a red next is going to be 7 out of 10 times 3 out of 10. And finally, the chance he went blue and then chose a blue the second time is going to be 7 out of 10 times 7 out of 10, which is 49 out of 100. Okay, so note, on each branch, so here you can 3 out of 10 and 7 out of 10 gives you 10 out of 10. 3 out of 10 and 7 out of 10, 10 out of 10 again. Same thing here, 10 out of 10. And here, if we add all these probabilities together, we get 100 out of 100. So I want you to click pause and construct this tree diagram. When you're ready, click play again. Okay, good, go. And just some information on that tree diagram for you to note. We put the outcomes at the end of each branch, so blue or red, and the probabilities then, they add up to 1, which we said earlier. So 3 out of 10 and 7 out of 10 and so on, 3 out of 10, 7 out of 10, and all those probabilities add up to 100 out of 100, which is 1. And we multiply along the arm. We multiply because it's and. But and, so we multiply. Good. Question. Rebecca has 9 coloured beads in the bag. 4 are black, the rest are green. She moves a bead at random from the bag and notes the colour and then replaces it. She then chooses the second bead. So this time I want you to draw a tree diagram showing all the possible outcomes. Calculate the probability she chooses 2 green beads and then a black bead followed by a green bead. So you're going to have to construct your probability diagram, like so. And what are the outcomes she can have? Black or green. Probability of selecting a black bead from the bag, 4 are black out of the 9, so 4 out of 9. And 5 out of 9. And then she has a second go. And again, we put our outcomes here, black or green, black or green. Probability of selecting a black bead is 4 out of 9, green, 5 out of 9, 4 out of 9, 5 out of 9. And then we can look at the outcomes then. 2 green beads, so we're going green, and then green again. So it's that one there. Green and green. It's going to be equal to 5 out of 9 times 5 out of 9, which is 25 out of 81. And the second one is probability of a black bead and then a green bead. So it's there, probability of black then green. That's equal to 4 out of 9 times 5 out of 9, which is 20 out of 81. Good. Hopefully you got those answers. And if we fill in the entire probability, then you can see all the other probabilities there. There's your green and green, which we've just done, and there's your black and green, which we've also just done. Good. Question 2. This time I want you to read the question. Peter tosses 2 coins. draw a tree diagram to show all the possible outcomes, and then use your tree diagram to find the probability of 2 heads and a head or a tail in any order. Okay, so construct a tree diagram and off you go. Click pause when you're ready, click play, and we go through the answer. Okay, so we've got our tree diagram. The 2 possible outcomes, head or tails. Probability of head is a half, probability of tail is also a half. And then we split it up again, because he does it twice. So head, tails, heads, tails. Half, 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 half. Pretty straightforward really. But you're getting 2 heads, so you're going heads and then heads again. It's going to be equal to, so probability of heads and heads is equal to a half times a half, which is a quarter. And then heads and a tail in any order. So you can do heads and then tail, which is probability of heads and tails. That's equal to a half times a half again, which is a quarter. But you can also go tails and then heads. So you can go that way because it's in any order. Heads or tails or heads. So that's equal to probability of tails and heads. That's equal to a half times a half, which is a quarter. So a head or a tail in any order, which means I've got to add these 2 together. So probability of heads or tails is equal to 1/4 plus a quarter, which is equal to 2 out of 4 or a half, then simplified. Okay, good. Some questions for you now. So your questions are on page 234 in the book, and questions are attached as well. So that's page 234. Attempt all questions then. 235, 236. Good. Questions 1 to 11. Good luck.